Question number 11. A company opens an account with an initial balance of $36,100. The account earns interest and no additional deposits or withdrawals are made. So the account balance is given by an exponential function A, where A of t is the account balance in dollars, t years after the account is opened. The account balance after 13 years is $68,071.93. Which equation could define A? Now we can see that from initial value of 36,100, after 13 years it has increased to $68,071.93. That means there's an increase. With that information itself, we can eliminate answer choice C and D because it is raising 0.05 to the power. These 0.05, they are less than 1, which means if you raise it to an exponent, its value will decrease. For example, if I show it on the calculator, if I raise 0.05 to the power of 13, it has become 1.22 e raised to the power of negative 17. It has become so less. Negative 17 power it has reached. So it will decrease. So we can eliminate those two choices. Now between A and B, we can observe that the initial value of 36,100 is there in answer choice A. So A is the correct answer. And there's another way to check this also. We can take this 36,100, multiply it with 1.05 raised to the power of 13. So 36,100, 1.05 raised to the power of 13, and see if we are getting the 68,071.93. That we can do it on the calculator. So you can clearly see that it has become $68,071.93 after 13 years if we are using the answer choice A. So this is one direct way of getting the answer. Now, how is the direct method of finding the answer? Since it's given that the account balance A of t in dollars after t years can be modeled by an exponential function, it allows that function A to be written as A of t is equal to n r raised to the power of t, where n is the initial value of the function and r is the constant related to the growth of the function. It's given that the initial balance of the account is 36,100. So it follows that the initial value of the function, or n, must be 36,100. So substituting 36,100 for n in the equation of this one, A of t is A of t is equal to 36,100.00 r raised to the power of t. This is with the initial value we are substituting. Then substituting 36,100 for n in the equation yields this. It's given that the account balance after 13 years, or when t is equal to 13, the value of A of t is $68,071.93. That means A of 13 is equal to $68,071.93. So that means we can take this 36,100 r raised to the power of 13 and equate it to 68,071.93. To solve for this r, we can divide both sides by 36,100. So r raised to the power of 13 will be equal to 68,071.93 divided by 36,100. So we can use a calculator for this, and we can find the 13th root of this value. 68,071.93 divided by 36,100, and we have to take the 13th root of this. So that will give the value of r. So let us do this on the calculator. So 68,071.93 I will divide it by 36,100 first. So I'll get this value, and I have to take the 13th root of this. So I will get 1.049999, that's recurring. So I will round it to 1.05. So that means 1.05 is the value of r. So substituting 1.05 for r in the equation, A of t is equal to, So A of t is equal to this 36,100, which was the initial value, r raised to the power of t, but now we calculated the value of r to be 1.05 raised to the power of t. So the equation is matching to, as you can see, answer choice A, which we found earlier also, but this is the direct way of doing. So it's better to know both the methods, so that in case something like this comes in the gradient section where you don't have a multiple choice, you have to calculate, let's say, r directly.